Welcome back. Continuing with chapter 5, we have section 5.4. Last time in 5.3, we did definite integrals where we had boundaries. For this one, we are going to not have boundaries. In fact, I'm going to ask you in your notes to correct this. We're not going to use boundaries at all for that. For this one as well. So I'm getting rid of the boundaries. And the thing we need to remember with indefinite integrals is that plus c. You can see plus c for every single one of these here. All right, let's get started. Example 1, we have cosine theta over sine squared theta. So we're going to end up with, I'm going to call this cosine theta over sine theta times 1 over sine theta d theta. And cosine over sine is cotangent. 1 over sine is cosecant theta d theta. And I want us to come over here. And this is sort of a list that you're going to need to know of all the basic ones. So when we hit section 5.5, we're going to have variations on all of these. So this integral is going to be negative cosecant. And don't forget our friend plus c. And for this one, I'm going to break up into several integrals. And notice I'm factoring out the constants. And I'm going to use power rule for these two. And for this one, I'm going to use this one here. We're going to get inverse tangent. So here we're going to end up with 2 over 4x to the 4th minus 6 over 2x squared plus 3 inverse tangent of x. And again, plus c. And I'm going to go ahead and reduce the fractions. I actually prefer indefinite integrals because I don't have to deal with all the numbers and everything that's a part of that. All right, this one we're going to do a little bit more algebra at the beginning. I am going to break this up into 3 integrals. All right. I'm going to note that I can reduce out here t squared and also t squared there. And I'm going to use power rule on all 3 of these. So now I have them in this form here. I'm going to end up with 2t plus, this is going to be, I'll write this one out. This is going to be 1 over 1/2 plus 1, t to the 1/2 plus 1, minus 1 over -2 plus 1, t to the -2 plus 1, and of course plus c. Let's clean this up a little. This becomes 3/2, which means it's going to be 2/3 t to the 3/2. This is going to be -2 plus 1 is -1. So that becomes -1 negative. So this becomes plus t to the -1 power. And even further than that, so not so bad. All right, next page. So here we're going to talk about the difference between displacement and distance. So displacement means the total area. We're going to account for the negative and the whole 9 yards there. So displacement is we're going to account. I worded that weird a minute ago. We are going to just integrate the whole thing. So we don't care if we have negative area or positive area or whatever. We'll account for that when we get to the total distance traveled, as we're looking at that. And here we have a particle moves along a line, so that the velocity at time t is t squared minus t minus 6 in meters per second. Find the displacement of the particle during the time period from 1 to 4. So this is just flat out find the integral. And I'm going to break this up into separate ones. Not all teachers do this. So I just want to warn you, they often just do it all one big thing. Again, the reason I do it is I would rather have a bunch of little easy problems than like one big, massive, kind of scary looking problem. So now we're back to the fundamental theorem of calculus. Let's clean this up a little. Minus, that's going to be 6 times 3, which is 18. And let's keep going. So 63 over 3 actually does reduce. Minus 1/2 of 15, minus 18. And 63 divided by 3. 63 divided by 3 is going to be 21. 21 minus 15 halves minus 18, which is going to be 3 minus 15 halves, which is going to be negative 9 halves. So you make that a 6. 6 minus 15 is negative 9. So this is the displacement, meaning the particle started one place, and how far away was it? It went down 9 halves. So now we're going to account for the negatives. This one, when we're talking about the distance, total distance traveled, is going to be a bit more involved. All right, so let's kind of graph this a little. So we're going to have a vertex at x equals negative b. B in this case is -1, so negative -1, so that's 1 plus or minus the square root. Negative b over 2a. Sorry, I was already jumping in the quadratic formula there. So that's going to be negative -1 over 2 times 1, or 1/2. And v of 1/2 is 1/4, 1/2 squared, minus 1/2 minus 6. So 1/4 minus 1/2 minus 6. Put that to a fraction, and we get negative 25 over 4. Which is 6.25. And it looks like we're going to have x-intercepts at, see, I'm going to go ahead and factor that. That's going to be t minus 3, t plus 2 equals 0. So we're going to have it at t equals -2 and 3. And a y-intercept at -6. So -6. And this is this was negative 6.25. And here's a half. And here we are at 3 and at 2. So our graph is going to look like this. And we are integrating from 1 to 4, which means 4 is out here. Which means we have some of it above the x-axis, and here's 1, and some of it below. And it's going to cross at 3. So our integral is going to have to look like this. So the distance is going to be the integral from 1 to 3. And we're going to have to make that area, it's going to be negative, but we're going to have to make it positive. Three to the third is 27 minus 1. 9 minus 1 is 8. 3 minus 1 is 2, so that's going to be minus 12. And overall, that's going to be a negative 22 thirds. And we knew it was going to be negative. Now we're going to go from 3 to 4. And plugging all of that in, four to the third is 64, minus 3 to the third, which is 27, minus 1/2, 16, minus 9, and then minus 6, 4 minus 3. And that gets us 17 over 6 when we get a common denominator. So the total distance or total area in our case is going to be 22 thirds, positive 22 thirds plus 17 sixths, which gives us 61 sixths. And they implied that this was in meters, so that's going to be a unit of meters. And 61 divided by 6 is about 10.167 meters. So we have our exact answer and our approximated answer. Hope that helps.